welcome everyone to Reimagining Text Fields in Compose. I'm Zach Klippenstein. I work on Jetpack Compose at Google. I'm not sure we'll have time for questions at the end, but I have a Slido up here if you want to scan that or enter that hashtag. Submit your questions as you think of them while I'm talking, and I'll try to answer them if I have time. So let's start by looking at text field. This is the material text field. This is kind of the standard demo use of it. But underneath material text field is something called basic text field. This is kind of the same API shape. It has a few more options for customization. It's a little bit more powerful, but it doesn't have any of the default styling stuff. But if you're building a design system specific text field, you're probably going to be building it on basic text field. So this has been around since Compose 1.0 and before that. So let's look at this kind of the two parts of this demo. So when you're calling the actual basic text field composable, you pass in an immutable. This is a common pattern in Compose. You pass in some immutable value that represents the current thing you want to display. In this case, it's the text. So you can pass in a string, and then you also pass in a callback that the component will invoke when the value changes. And the expectation is that you, in your callback, you update some state that'll trigger recomposition and pass in the new state on the next frame. So to do that, you typically use mutable state. In this case, we're creating one in the composition, so we use remember, mutable state of. Every single Compose talk ever probably has this slide in it, so I'm not going to talk about it too much. But you have to make sure that whatever you do with the state change, it triggers recomposition. So the current text field is not perfect. There's a few bugs. A lot of you have been filing bugs. Thank you very much. It might not always seem like there's a lot of activity, but we do see them. And part of the reason why there's not as much activity as you maybe want to see on these is the current implementation has quite a bit of tech debt. It's been around, like I said, for a while. And a lot of the implementation was done before a lot of the current Compose best practices and idioms kind of were established. So it's hard to, a lot of the time, to fix bugs with it. It can also be hard to use sometimes. So because we give you full flexibility about how to store and update the state for the text field, it's really easy to do something like hoist it into a view model, and then, well, instead of using mutable state, maybe you use mutable state flow, and all of a sudden you accidentally have introduced some sort of asynchrony into the update loop, and that just breaks everything. And this is I think happens quite a lot. My colleagues Ale and Sean have given multiple talks and blog posts about this. Other parts of the API are also tricky to use. So visual transformation is real hard because the concept is fairly straightforward. You get in the current string that you're displaying, and you return a different string. But we also make you return a mapping. So this is like two functions that do mapping in both ways from indices in the visual string to and from the original string. And this is hard to do well, and sometimes isn't even enough information to do what we need. So one tricky case here is take a string, and you have a visual transformation that adds some text into the middle of it. When you're doing the mapping, we're using the result of the visual transformation to look at where the cursor is, and when you're dragging the cursor around, that's in the transform string. So we're going to always be calling that offset mapping function to translate the index back into the original string. But in this case, there's a whole bunch of indices in the transform string that match the same index in the original string. So we have to store kind of our own version of that state. And so now we've got a second source of truth, and there's also there's no way for you to know that the cursor is currently in the middle there. And if you want to adjust the cursor programmatically, there's no way to do that. And it gets trickier too. If you remove text, there's other things where like we don't have enough information from that mapping function. So this is a really tricky one, and an example of an API that is just kind of broken by design. So we looked at a lot of this stuff, and we asked ourselves, if we didn't have basic text field today, how would we design it from scratch? So about a year ago, we realized that we had to kind of do this project. So we we tried to do some really high-level scoping and estimation just to figure out, like, is this something that's going to take us a week to fix, 6 months, or like 10 years? Who knows? And of course, it's probably going to be closer to 10 years. But we figured that we could probably do most of it around roughly the order of like a year. So we were kind of in the middle of the year when we did this, and we were like, all right, let's hold this for the next annual plan, as I'm sure a lot of you are familiar with that process. And so we spent the next 6 months trying to fix the most critical bugs and just kind of plodding along. And every time we did, we were like, oh, we really need to just like fix this, like just kind of do the whole thing. So January rolls around and we kick off the project. We start brainstorming. We've been thinking about this for a while now. We've kind of internalized a lot of the biggest problems, and we are full of ideas of different things we can try. So we start writing some prototype code. We start writing design docs and just talking about this stuff. We're trying out all these wild ideas, and we realize that we're changing so many of the fundamental parts of this that we need to make sure that we have that right and validate those kind of designs before we go off and like polish it and build everything else on top of this. So we decided to run a user study. User studies are a really cool tool that Google sometimes uses to do this sort of early validation. And it's really nice because, you know, we're doing our design and we're just a bunch of, you know, we're sitting there, we're always in the framework code and stuff, and so we have some idea of what makes sense, but we're not sure if that's going to make sense to somebody who is just coming out of college, or maybe even still in college. Maybe this is their first time looking at UI programming, and they're like, I'm going to write a hello world, and I'm add a text field to it. And if you have to have, you know, the CS degree just to do that, and then it's not great. So we started by looking at what did we actually want to learn, and we kind of wanted to make sure that the API was somewhat easy to just grok initially, and that the concepts that we were for various features made sense together, and that it was flexible enough to do some interesting things with it, and be able to like figure out how to do that stuff just by using the API and some docs. So once we knew what we wanted to learn from the study, we prioritized the things we were going to build based on our giant brainstorming doc. And we decided to focus on things like basic state management, filtering, and a few other things that you'll see in a little bit. And we decided to leave some things for later. So we didn't worry too much about implementing user gestures, because the goal of this study is to validate the APIs and the developer experience using this. So making sure we get all the magnifiers right and all the handles and dragging and stuff like that wasn't a top priority. Another thing we decided to leave off was worrying about style text and editing style text. This is something that is currently, it looks like it's supported in text field, but it isn't really. And we want to support this, but we want to make sure that we get the basic APIs right so we can build those on top of those and you know, not put the cart before the horse, so to speak. So this isn't an exhaustive list, just kind of an idea. So we prioritized stuff. We started building these features that we had decided to build. And we're working with a professional researcher. So something that is cool about Google that it hasn't been the case at other companies I've worked at is we actually have like a team of people who do this full time. And so it's really nice because they have a huge pool of people that they can reach out to that have volunteered to help out with this sort of study. And they help us figure out what the study is going to look like, plan the timeline, set up scheduling, figure out how to plan the study to get the information we actually need. And then they actually execute the study and talk to participants and set all that stuff up and gather all the data and summarize it at the end. So it's really cool working with someone like this because they kind of train you how to do it, and you just do some of the plug in your engineering stuff when you need to, and you get lots of information. It's great. So we got the prototype kind of ready to go, and the study plan is all there. We start talking to participants. So we found 16 people, and we scheduled an hour interview with everybody. And we just kind of learn about their background and explain the project and show them the docs. And then we spend about half an hour watching them actually start to code. And so what are they coding? Well, we put together a kind of a take-home project that if you've ever done like a take-home interview, it's kind of like that. except we're not evaluating them, they're evaluating us. So we put together this little project. We watched them kind of start to code on it. And then we said, all right, you have about a week. Don't spend more than a couple hours on this, but as you're working on it, take notes. And we gave them a doc with a template and everything. And so just write down what your impressions are and any stuff you run into or any problems. Just keep track of everything. And then after that week, we met with them, with each person for another hour. And we kind of went over the doc and we asked questions about problems they'd had or if they needed clarification or we needed clarification. It was like a nice conversation. And we just got as much information as we could. And so the take-home project that we designed, we basically just built a little fake email app and then removed all the text fields from it. And that allowed the participants to focus only on actually the text field stuff and none of the rest of the project. And then we just asked them to put the text fields back. So we split it up into about 4 different tasks. There's 4 different screens with various type of text field features. And we wrote some kind of developer-android.com kind of style docs and tons of docs in the code. And here's all the documentation. Here's the code kind of skeleton. Go off and have fun for a week. And then we got all this information, and our researcher helped do all the studies and record everything and put it together. And we came up with a list of stuff to do. So if this sounds like something you might be interested in doing, we'd love for you to sign up and maybe help out with one of these studies in the future. It can be kind of fun. A lot of the participants in our study said they actually had a lot of fun working on this because you're playing with new Compose APIs. I'll show this URL again at the end, but feel free to, take a picture now. The Compose team has done user studies for all kinds of stuff throughout the lifetime of the project, and that's just the Compose team. Excuse me. That's just the Compose team. There's all kinds of studies going on all the time. So there's a little form you fill out here, and you can sign up and help out with this stuff. So if you're interested, we'd love your help. So we've got all this stuff from the study now, and that brings us kind of to today. We're taking our designs and our initial ideas and iterating on them based on this feedback. And so what I want to do is give you a little peek of what these things actually are and what we're kind of working on. And I'd love to hear your thoughts about this as I go through it. So if you have questions, there was that Slido link before, or find me after the conference. I'll have contact information. However you can get a hold of me, I'd love to hear your thoughts. One caveat here is that all of this stuff is super heavy development. So most of the things you see here will probably be obsolete in a week, but this is kind of the direction we're going. And so I just wanted to give you a little kind of preview into the process. This is the exciting part, so I gotta just hydrate. All right, let's dive in. So the first thing, the basic text field composable itself. With the old code, you pass in the text and a callback. The new code, we have a state object, and you just pass in that state object. And that state object contains the text, and it gets updated. So how do we create the state object? Instead of calling mutable state of, we have a special function that you can call to remember a text field state. And you can pass in an initial string. And this is actually one of those things that the user study was really helpful for. We initially did not have this initial string parameter here because we thought it would be too confusing because it's similar kind of to the old API, and it was just a huge pain for everybody. So we were like, okay, we were wrong about that assumption. So we put you're going to put the initial string back in there. So you use this and you create a state thing. And I'll talk a little bit about exactly what this text field state thing is in a bit. But first, I want to talk about how to use it. So in the old world, you're creating a mutable state of text. And if you use property delegation, then you basically just have a string variable. And you can just use that string variable wherever. You can read from it in the composition or wherever else. In this case here, we're passing it to the text composable. So when the text field changes, we automatically update the text. With the new API, it's almost that simple. There's a text property on the state. And so you call that, and you get the actual contents of the field. This is also something that you can hoist up into your view model. So if you hoist a mutable state, it looks something like this. It's basically the same code from the previous slide, but without the remember. Or you can also do it with mutable state flow if you're feeling adventurous. And you have to be extra careful here because of what I mentioned earlier about the asynchrony. But you can do it, and then you just need to provide a way to update the text so that you can call that from your composable. So with the new API, you hoist the text field state thing itself. And in this case, you're just calling the actual constructor, not that remember function, but it's kind of the same idea. You pass in the initial text, and then you refer to that from your composable. What about observing changes to state? So in the old world, if you have a mutable state of a string, you can use the snapshot flow function to get a flow of changes to that state. And there's a typo in that thing. I guess there's no syntax highlighting in this new tool I'm using, or at least validation. But and then you can just use all the flow APIs to do whatever you want. Or if you're using mutable state flow, then it's already a flow, so you can kind of skip that snapshot flow step. This is just as easy with the new API. You actually have both, or you have two kind of options. You can get the text value as a flow from the text state object, and then do whatever you want with that. Or we also give you a little, if you're just immediately calling collect latest, we give you a helper called, well, right now it's called for each text value. That name is still kind of being settled on. And then that's just another suspend function, and you can do whatever you want inside of that. This is, again, one of the things that came up in the study was the name of this function wasn't really clear, and but it was also nice to see, like, some people were excited about the fact that there was a flow function here because they were familiar with that, and some people had never heard of flow before, so it was nice to have kind of both options. One example of something you can do with this is debouncing. For example, if you have a search field and you don't want to search on every key press, but wait for a little timeout, you can do this with flows using the debounce operator, or you can use just a regular coroutines delay. And whatever feels more natural to you, or if you have more complex code, you can pick whichever one makes sense. And really, under the hood, that for each text value is literally just calling snapshot or collect latest on the flow. So it's there's nothing fancy there, and it's also using snapshot flow under the hood too. So it's all really just helper functions. So that's kind of observing changes. What if you want to set the value of the field programmatically? In the old world, you could just set the value. You're passing that in to the composable, and so you can pass in whatever you want, and you can change that however you want. So in this case, we have a little prefill method on the view model that just sets the value of the flow. And in the new world, text state has a couple of setters on it. Set text and place cursor at end here is verbose, but when you set the text, we want to also say where the cursor is going to end up after you set it. So there's also like a set text and select all. And if that's too coarse grain for you, if you want more control, you can also dive into the next thing here that I'll talk about. So if you want to edit the text instead of just completely replacing it, right now, the way that there's a couple of ways you can do that. You can use nice kind of fluid functional style operators to modify the string, or you can get a string builder, something mutable, and then do your modifications in there, and then set that string back into the actual text state. So with the new API, this is actually a little bit easier. We give you an edit function on the state, and this gives you a type called it's a text field buffer, but it's basically a string builder. And so all of the whatever you want to do with the text, you can do it with a mutable object. And a lot of people, and this came up in the study too, that like, oh, this is mutable. I don't want to use this because mutable is bad and it's dangerous and scary, and that's normally right. That's a good instinct. But because this is like a special API on this text field state, we can make that safe. And so it's there's no race. You don't have to worry about races here. You don't have to worry about like accidentally stomping on someone else. When you call edit, we give you your own mutable kind of string builder thing, and you don't have to worry about all the normal stuff you would with mutable state. And because you can mutate it in place, if you're just making small edits on a larger field, you're not copying this giant string every time. And internally, we can optimize all the actual whatever copying we actually have to do and make sure that this actually works with the state system. So when that edit block returns, we atomically update the text that the text field state is holding, and anything that's observing that state object will see the new text. So let's look at the actual text field state class. It's got a constructor. You can pass in an initial text and initial selection. And then it's got a couple of properties, so you can pull the text out, and it's a char sequence. And you can also get the current selection. Or if there is no selection, then this will just be a 0 length range, which means cursor. There's also that edit function on there, and that just takes a lambda that has a text field buffer receiver. And so this text field buffer thing is, as I said earlier, it's basically just a string builder with selection. So you've got, it implements char sequence and appendable. It's got a length property. You can append to it. You can replace text in it. And basically anything you can do with a string builder. We're still working on building out this actual set of helper methods here, but you can just change the text as much as you want. So you can replace a regex. The possibilities are virtually endless. And then it also exposes a mutable selection property. And so you can change the selection from inside this text buffer. So if you want to, when you're making changes inside of an edit block, you make your text changes, and then you can, we try to keep the selection and the cursor updated as you do that, but if you want to change it somehow, you can just set the selection property and update the selection or the cursor position. So that's state. So it's backed by snapshots like everything else in Compose, and so it works like you'd expect if you're just reading the text value from a composable. It's observable via snapshots or flows, whatever you want to do, whatever makes sense for your code. And you can edit it via mutable buffer, and you can hoist the state as is a common practice with Compose. So let's talk about another feature. Now that we've taken you out of the update loop, you no longer have that onValue change callback. And that callback was useful for doing things like rejecting certain changes. So in this example, I want to write a text field that only accepts numbers. So I'm going to write a really basic version of a digits-only filter. And if the new text if the new text has something that's not a digit, it'll just reject it and revert back to the old value. And in a production implementation would need to handle a few more edge cases than this, but it gets the idea across. So with the new API, we have, since you don't have that callback anymore, we have an explicit filter parameter and this text field filter type. And it's basically just like a function that gives you a text field buffer again that we just saw. And you can look at that. That buffer has the new changes, and you can do whatever you want with that buffer. One thing I'm not showing here, but it also actually has specific information about what changed. And there's no way to get that in the current API. You just get the old string and the new string. There's no way to figure out what letter was just typed or something like that without doing a full diff. And so with this API, we run this after the actual input, not it's very specific. We run it right after the input before updating the state. And we tell you what was actually changed as part of this update. And so you can, if you have logic that needs to run on that, you can see was text deleted or was something just inserted brand new, you can run that logic here. And because it's a separate type, you can factor it out into its own object, for example. So here we have a digits-only object that kind of pulls this logic out, and now you can use this anywhere in your code base and say that I want this text field to only be digits. And we can even ship this with the library. So for some basic filtering cases, we can, digits only, for example, or maybe a maximum length of a text field sort of filter, we can ship that built in. And speaking of max length, we can also chain filters together. So if you want to only allow digits and then keep the length at 10, you don't have to write a separate filter for that. You can just chain them. They're composable, as you'd hope. So if you have a text field that only accepts digits, you probably also want to show a keyboard that only shows digits. So you can do that with the text field by passing in keyboard options. But because that's something that's probably going to be true for anything using this filter, you can also specify that on the filter itself. So when you write a text field filter, you can optionally override this keyboard options property and configure some default options for the keyboard. And this is overridable. If you override this by passing in a keyboard options on the actual composable, you can override it. But this is kind of like a default thing that, so if you just pass in a digits only filter, it should just work and it should make the keyboard do what you would expect. So that's kind of filtering. One of the most valuable things maybe from the UX study that we did was we weren't quite sure how to. We thought maybe we could solve the visual transformation use case. I talked earlier about visual transformation and how sticky it is. We're like, maybe we can get away with just using this filter API. So we didn't really build in a visual transformation API for the study, and we just wanted to see if people could figure out how to do it with filtering. And it turns out that was a terrible idea. It did not work at all. Everyone was like, this is just impossible. Even I, when I was doing a dry run of the study, was like, well, maybe I'll come back to this later. Like, this is tough. So we can do a lot better than that, and I'll talk a little bit about some ideas there, but we're still trying to figure that one out. So that was just a kind of an example of the user study kind of really providing some useful feedback. Let's talk about a different API. So right now with basic text field, if you want to control the height of the field, you can pass in this min-max lines parameter. There's also a single line parameter though. So what's the difference between passing max lines 1 and passing single line true? There is actually a difference. It's not obvious at all. It's actually fairly complex, and there's a number of different kind of dimensions to it. And because these are all just 3 different parameters, single line, min lines, and max lines, you can pass in values that make no sense. What does it mean to have a single line field that must be at least 5 lines? It's ridiculous. So we wanted to fix this problem as well. So we replaced the set of parameters with a single parameter called line limits. And this basically is just a configuration for everything that those other parameters kind of described. So in the case where you're passing single line true, you no longer have to wonder which one of these takes precedence. You just pass in single line, and that's all you can do. If you want to have a multi-line field, then you say line limits is going to be multi-line, and that's when you now have the opportunity to specify minimum and maximum height in lines. So some other, the implications of these, again, I said there's kind of a few dimensions here. So when a single line field will never wrap the line to the next line. It just joins lines and shows everything on the same line. If there's new lines in the text, it'll just join the lines. And it also doesn't let you enter new lines into the text. It's always a fixed height of 1 line tall. And if the text overflows, it'll scroll horizontally. Multi-line, on the other hand, will always wrap lines if they're too long. And it'll allow you to enter new lines. And it'll render new lines in the text. It will shrink and grow as necessary within those constraints to show the text. And it will scroll vertically instead of horizontally. And speaking of scrolling, we get asked a lot, well, the field can scroll. How do I read that scroll position or control it? And there's no way to do that with the current API. So we just pulled up the scroll state that we have internally and made that part of the public API. You're welcome. I mean, it seemed like the most obvious change, so we were like, oh, why not? So this just uses the same scroll state API that vertical scroll and horizontal scroll use. And all of the APIs on there for reading scroll position, animating it, those are all, you just get those kind of for free. And the orientation that the scroll happens on depends on that line limits, single line versus multi-line. So let's talk about passwords. Today, if you want to make a password field in Compose, you use the same text, basic text composable or text field composable, and you pass in a visual transformation. And we give you a special visual transformation called password visual transformation. And this replaces all of the characters with some sort of obfuscation character. I think it's a dot by default. And that's kind of it. It's not terrible. but it's actually missing a few things. You kind of want to make sure that you specify the password semantics, and you got to make sure the keyboard's configured to show the password keyboard in case the keyboard wants to show something special there. And you also need to make sure that like cut and copy and dragging, you probably want to disable those so you can't just like copy the password out of the field. Pasting is obviously something you want to allow, but not copying out. So I think right now we do some of this based on the actual, we treat that visual transfer, that type as a special type. And if you pass in a password visual transformation and the class matches, we do some of this stuff automatically. But if you want to write your own password transformation, that doesn't happen, and there's kind of no good way to like replicate it. So instead, we're going to be, we want to introduce a new field, secure text field, a basic secure text field, which kind of has the same general API shape as basic text field, but it does all this stuff for you. It doesn't let you pass in a visual transformation, but it does let you configure the actual obfuscation character. And it does all the other stuff here. It supports autofill correctly, and it automatically configures the IME and semantics and all that stuff. So speaking of visual transformations, I mentioned earlier that we're not quite sure what this is going to look like. We're still thinking about the design. So this is typically used for fields where you want to like add some sort of templating characters, or you're entering a phone number and you want to put some stuff in there, or like a credit card number. You want to put some dashes or something like that. So we're still trying to think about what this API is going to look like. What we have right now is for a kind of subset of that case, we have a one-to-one transformation for code points. So I don't want to get into it too much because that's probably a whole separate conference. But code points versus characters, you can basically think of a code point as a character. It can be basically two characters in some cases. But you can look at the slide and just kind of replace code point with char everywhere and get the same idea. So this just is a function that gives you the index and the character or code point at that index, and you return something to replace it. One-to-one mapping, and that's it. You can't insert extra text or remove text. So, and that is something that we are aware that we need to support, and we're trying to figure out how to support it. So we don't really have any designs for this yet. So I'm going to show you something that I literally just like made up off the top of my head for the slide this morning. I have no idea if this is any like, good idea at all, but we could give you a function where you get the current text in, and this is the text from the text field state, and the text that will be changed when something is entered. And then we give you some sort of a scope receiver thing on here, and we basically give you these methods like insert visual text. So you could say, like at this index in the source string, I want to add some characters. Or maybe you want to replace some range in the source text with a different text. And then we can then do all of the offset mapping calculations for you so you don't have to worry about it. And we can also like ensure that you don't do things that are just like invalid. Like replacing a thing with an empty string is something that doesn't really make sense, so we can like throw if you do that or something eagerly instead of the very cryptic exception that you might have seen when you do a bad offset mapping today. So again, I have no idea. This is just like, I just made this up. But we're still thinking about this and trying to figure out what would work. So if you have ideas about it, or if you have your own thing that you've built that worked well, or you think this is a terrible direction in general and you just want to go back to visual transformation, I really want to talk to you, actually, if that's the case. But yeah. So this is just kind of totally made up. So that's just kind of a recap of, or that's just kind of an overview of some of the new things we're thinking about doing here with this API. And we talked about there's a new text field shape with a different set of parameters. We've got this text field state, text field buffer for actually representing the actual contents instead of using mutable state. A dedicated filter type with some built-in filters, line limits configuration. The scroll state is now exposed, and a dedicated password field. And we're still trying to figure out visual transformations. So again, I said I'd love feedback on this. And if you have feedback after watching this, awesome, I'd love to hear it. But we also have been shipping this in the latest alphas. So it is actually in the Compose alphas. I think it was in the last 1.5 alpha, and it'll be in the 1.6 alphas going forward. It's in a temporary separate package now from the rest of the compose text stuff, just to keep everything really separate. Basic text field has a different name, basic text field 2, also temporary, just to make sure that it's really clear that you're using this other thing. But it's there in the alphas. It's not in the betas. We removed it for that, but it is in the alpha. So if you really want to play with it, this is not production ready at all. Like the gestures don't work. A lot of stuff doesn't work. But if you have some tricky problem that you've been trying to solve with basic text field, and you can't figure out a good way to solve that problem with that API, I'd love for you to give this a try and just see if it lets you write the code you want to write or how it feels. Again, the name is temporary. Everything is changing here a lot. It'll probably change with every alpha release. But we'd love to, if you're feeling adventurous, just to see what you think. So that's pretty much it. We've got a lot of bugs in the current implementation, and the best way to really fix this is we got to fix some of the API design issues. So that's why, again, introducing new API, always rough. We know that. And we also plan to support the current composable with the current API shape as much as possible, support that going forward as we do this and kind of forward to the new implementation under the hood when we can. So even if you don't upgrade to the new API, you'll hopefully be getting a lot of the advantages and the bug fixes and stuff that we're working on. But there is a new API if you want to take advantage of it. The current code is super experimental, but it is in the 1.6 alphas, and a lot of this is being driven by user studies. So if you want to participate in future user studies at Google, please go to this link and sign up. We'd love to have your help. So that's the talk. Again, feedback. I'm on the Kotlin Slack. You can file issues on the issue tracker if you want. I'm on Mastodon here with my link, and my teammate Halil is on Twitter. We're working on this together, so feel free to reach out to either of us or both of us. And if you want to get these slides, there's a QR code.